Hi everyone, welcome to the Vega Workshop for Hack the System by Encode. Today we're going to be having a presentation from the Vega team on what Vega is, their challenges and how to kind of get involved in developing with Vega. So just in terms of the hackathon in general, we do have a few upcoming events next week, which will be an AMA session with Arthur Brightman at 5 p.m. on Wednesday. And then also we'll have a Fluence workshop at 5:30 p.m. on Thursday. So make sure to come along to those. They should be fantastic events. But yeah, so now I'm going to hand over to the Vega team to give their workshop for the Hack the System hackathon. Over to you.
So just covered before, brief agenda. I'm going to cover a quick overview of what Vega protocol is, cover off the challenges, a bit of an overview on the dev resources, and then just jump straight into the workshop. So kind of on here we have I guess, a kind of high-level description of what Vega is, which is a decentralized kind of network for trading derivatives, and highlighting the fact that it's an independent blockchain which works with kind of major general purpose chains that's optimized for trading, specifically some of the points that we see on this slide around fast, decentralized order books, allowing anybody to kind of create markets, preventing things like front running, and offering traders kind of good amounts of leverage. So solving some of the issues that we see with decentralized trading applications on Ethereum and other general purpose chains. And the fact that it's an independent chain allows us to optimize, many of the aspects that have made it difficult to kind of scale decentralized trading, specifically of derivatives on some of the larger chains so far. And then in the long run, we envisage being able to have bridges to other blockchains as well, so not just Ethereum. But today we bridge to Ethereum so that people can use kind of Ether, stable coins, and other kind of ERC20 assets as collateral for trading on the Vega network. So that's kind of a bit of an overview. We'll see more in a minute when we jump into the demo and the workshop, but that's a kind of high level overview of that. And the challenges we've got today fall into two categories. So you've got kind of an easy challenge, if you like, and a medium one, which is a bit more involved. And for the medium challenge, we've got a £10,000 prize pool, and for the easy one, it's kind of £100 each. So for people who successfully kind of achieve that, the easy challenge is kind of building a trading bot that's profitable for at least one day. So hopefully not too difficult. And the medium challenge is quite broad, really. And there are some examples here around the kinds of things we'd want to see, but basically to build a kind of decentralized application on top of Vega, which exposes many of the kind of unique aspects of a decentralized trading network, where all of the information about the people on that network is public and accessible. So that could be leaderboards showing the profitability of people on the network. It could be tools for helping people manage their risk, possibly even things around governance, and how the network is governed in terms of the creation of markets and stuff like that. So there's lots of interesting things to do, and digging through the documentation and looking at the kinds of things that are available in the APIs should be a good place to start as well for inspiration. And we'll see some of those docs in a minute as well. And then on the developer resources section, we've got our docs hosted at docs.testnet.vega.xyz, which we'll jump into in a minute. And if people get stuck or want to talk about ideas, then please come join the Discord. There's a dev channel in there for talking about all kinds of detail on building things, which many of us are happy to help out with. And yeah, that's it. I mean, the website is vega.xyz, and that's our Twitter. So with all of that said, I'll jump into showing a couple of the kind of things that we'll be looking at whilst building a couple of small things on Vega just now. So let me just open this. So one of the first things we need to look at before we can actually build anything is the Vega wallet. So we're going to go through setting that up in a minute. And this is hosted on our GitHub at Go wallet here. And this is a kind of, at the moment, it's just a command line utility that we use to manage our private keys for the Vega blockchain. So I've already got this set up from earlier, but I'm just going to start it now so that I can show you the console. Which we'll be using to look at the kind of trading that's going on the network. So when I start a local wallet there, which you've just seen, this is a service that actually has my user details set up in already. We'll come back to that in a moment. And it's opened a proxy through to the Vega console, which is actually running also at testnet.vega.xyz, I think. It's .trading, which is also running here. And you can connect to this using a Vega hosted wallet or a local wallet for development purposes, and kind of for security purposes, it's better to run one locally. So I'm going to show that as well now. And when you run it locally, it pops up on localhost as well. So here I can connect to a wallet that I created earlier. And I'll show you how to create one in a moment as well. And this looks, kind of very much like any trading interface or exchange that you'll be used to seeing. Very, very fast and responsive, and actually is all running behind the scenes on a decentralized network with a handful of kind of validator nodes that we're running on the testnet at the moment. And you can see lots of pieces of information about markets. And here we have a Aave DAI market that's being created, meaning the market settles in DAI, so you need DAI to trade on here. And if we look in my wallet, I've got this test asset TDAI, which is a Ropsten asset for trading on this network. And the position down the bottom here, where I'm currently losing 6 DAI that I created earlier whilst I was testing some things. So that's kind of an overview of the console, and we got here by running the wallet service. So I'm just going to show you how you would actually set up your like a new key in the wallet to get going with. So I'll just stop that. And if we run this, you can see there's a few different things we can do with the local wallet service that we were running a minute ago. The main one being generating a key. So if you want to generate a key to use, you would need to just run the gen key command. We'll call it user. Let's see, what did I do wrong there? Okay, I don't need to put -p. It's going to ask me to enter a password, so I'll just give that password 123. And you can see here it outputs a public key and a private key pair. Obviously, I can't use this now because everyone here has seen it, but the public key is essentially, synonymous with an Ethereum address or a Bitcoin address. It's an identity on Vega, on the Vega blockchain. So once we've created that user, as I've just done now, called user with password 123, I could go back to running the service, and I can connect now as that user if I want to. So I'll do that just to show you the fact that this user now doesn't have any assets on Vega, so it's going to pop up and say the key has no assets. And in order to trade on here, you need to kind of have collateral on the Ethereum bridge contract that I talked about a little bit before. And depending on the market you want to trade, you'd need to pick the asset that you need here. So for the examples that we're going to run through on this workshop, we're going to be using the Aave DAI market, so we need some DAI. So we just go here, we can click deposit. It pops up with MetaMask. And we don't have any of the kind of fake DAI asset at the moment. So in order to get that, we first of all need to, I think we do have some ROPs ETH in this address. Yeah, so you need some, we're connected to the Ropsten testnet here because that's connected to the Vega testnet chain. And so you obviously need some Ropsten ETH to request the TDAI from a smart contract that we've created on Ropsten. Obviously on a real live network, that would be real DAI, but this is just to give you some kind of test assets. So we click get TDAI, and then there are a few steps involved here which require waiting for confirmations on the Ethereum chain. So I just wanted to show this so that you know that you need to do this before you can really start building anything. But on the address that I created earlier, I do already have some. So if the Ethereum confirmations are taking too long, we'll switch back. But you can look here on Etherscan and see what's going on, which is we're waiting for this to confirm, and we've got a pending transaction on this base faucet contract, which is just a faucet for distributing tokens that are compatible with the Vega testnet. So we'll wait a minute or two for that. Hopefully that won't take too long. Cool, that's done. So now I have, I think 100,000 DAI, and then that's been done to use maximum, and I can now deposit that in a separate transaction. And the deposit transaction is worth also just talking a little bit about, because it gives an overview of kind of what's going on behind the scenes. We just wait for this to pop up here. When I do this deposit, what I'm essentially doing is talking to the Vega bridge contract, which all lives on Ethereum and emits events which get listened to by the Vega chain. So the Vega chain understands that I've moved my DAI into a smart contract, and in doing so, I've effectively deposited it to a location that I don't control and is controlled by the nodes on the Vega network. And so I can now use that for trading on the Vega network, and all of the accounting of how much DAI I have when I trade happens on the Vega chain as I kind of open and close positions. So this one may take a little while. I don't actually need to wait for that because we can actually just use the user that I set up before. But when it finishes, you would see that you have the balance now inside your Vega account, and you can use it to place trades. So because I don't know how long this is going to take, it waits for 3 confirmations, but because it's Ropsten, it's slow. It can sometimes take a little while. So I'm going to just jump out of here and log in as the other user that I created, so we can jump straight into the coding side of things. So this user, you can see, has 99,900 DAI, and up the top here you can see that's the available balance, and then because we have an open position down the bottom, we're using 31 of those as margin for our open trade. So that's kind of an overview of like using the wallet service to set up some keys, and deposit, how you then deposit using the faucet so that you can build an application. And if we just look at this here, we've got this is the public key that has the 99,000 DAI associated with it. So that's the key that we're going to use in our trading application to say, we want to trade on behalf of this public key, and we'll be signing the transactions against into Vega with the associated private key that gets generated in our local wallet. So I'm going to fire up now some code that I prepared earlier, and we've got two things going on here, which I'll give a quick overview of. We don't need to look too much at all of the code, but we've got two scripts, one called stream and one called trade. These are complete examples, and we're going to kind of build these back up now a few lines at a time. And the stream script is connecting to Vega over WebSocket connections to basically stream information about markets and positions. And the trade one is just firing random trades at the network. And so we're going to try and build both of these now by looking at the docs, copying and pasting from the complete examples, and running it periodically to see what's going on. So that's the bit that I'm going to run through just now. And I'll just create a new file called, let's say, we'll do the stream one first. So I'll just do stream2, which is going to be an empty Python file. And we'll look at the Vega docs to try and build this back out piece by piece. So if we just jump into the docs for a second, the docs.testnet Vega the docs are hosted here, and we have a few different APIs. We've got gRPC, REST, and GraphQL. And the real-time streaming of data is best done using the GraphQL interface, typically over a WebSocket connection, or you can use gRPC, but the GraphQL interface is quite flexible in terms of being able to kind of define lots of different queries to get data out. So we have these GraphQL docs which define all of the different sorts of queries you can run. And I'll just show you one example now in the playground, just to give you an idea. So let's say we wanted to just look at markets. You can go into here, you can say query market, query markets, you give an ID. We need to get a market ID, so we can do that by going to the API. I think there's a markets endpoint. So this is the REST API. I happen to know that URL off the top of my head. And we can grab the ID for Arve DAI. And let's stick that in there. And you can build these kinds of really dynamic queries that retrieve any of the kind of complex structures from the Vega network over GraphQL. And you can query them in a one-off fashion like that, or you can create subscriptions, which is what we're going to do for the, which will keep streaming updates to you, which is what we're going to do over the WebSocket. So these docs are really helpful for working out kind of how you want to define your query that you're going to run. And then a lot of the other stuff we'll do in this script for streaming data is a bit of plumbing around kind of what you do with the data once you've got it, to maybe make it useful. So I'll jump into the code, and I'm going to copy and paste some bits from the complete script just to kind of show you what's going on. So we're going to need to import a few things in here in order to create our WebSocket connections. And they are going to be these lines. And I'm actually just going to delete some of that for now, just to simplify it. So, and I'll talk about what's going on. So we're going to add a simple query, which is based on the GraphQL docs that you just saw. And this query is going to just query market data for the Aave die market. So we have the market ID for Aave die. We've built a kind of GraphQL subscription here, which says, for this market ID, get me the mark price, the best bid volume, the best offer price, and the best offer volume. And we actually request the number of decimal places for the market, which I'll explain a bit in a minute. And then we define a bunch of functions here which are needed in order to use a Python WebSocket library. So don't worry too much about those. They're basically asynchronous functions which fire when the WebSocket connections open or close, or when a new message is received. And then we've got, I guess the onMessage function is the most important one, which is where we handle the message that comes back on the WebSocket. So at the moment, I'm just converting a string into a dictionary in Python, and I'm just going to print it to the terminal. And then when we run this script, it's going to call connect, which is going to connect to the Vega node. Actually, this is connecting to the load balancer, which sits in front of the Vega nodes on the network. And this is going to connect to that load balancer over WebSockets. And then when the connection opens, we call init subscriptions, and this is just firing off some initial requests to say, I want to connect, create a connection to this particular subscription. And I think I just need to add this subscriptions array, which gets used in there. So this is kind of the simplest bit of plumbing we can do to connect over a WebSocket connection, and start to get some data back and have a look at that data and see what it is. So with that relatively sort of complete example, we can try and run that, and hopefully hopefully it doesn't hopefully it works first time, so we'll see. So it's stream 2, and yeah, cool, it's working. And you can see this is now streaming just some really simple information from the Aave die market back over a WebSocket connection. And what it's actually, you can probably see if you look closely that the price is changing ever so slightly, and the bid volume is changing each time. So that's kind of step one for getting some data back. It reconnects if you try to kill the connection. So we're going to need to kill the process. But so yeah, so that's streaming some data back, and then you can stream anything back that you see in the subscription part of GraphQL. So candles, orders, trades, positions. It gets quite complicated, and it's far too much to go into in this workshop. But I just wanted to kind of give you an overview of and show you how you can get that real-time data back over WebSockets. Because in particular with trading networks, there's lots of information, and you know it's not practical to query via the REST interface for this sort of information all of the time. You want a real-time stream if possible. And then there's a few things we can do to just build on this really raw implementation, and that might be adding subscriptions to other different types of data, and it might be actually then kind of doing something with the message that we receive. So now I'm going to add into here a stream that returns position data, and I'll just grab that from this file. So for that, we'll have another query called position data query, which we'll define in our script. And that's going to kind of pass in a party, which is your identity, the one that we deposited the fake die to, and a market. And it's going to say, get me the positions for this person on this market. And again, in the same way we define the fields we want for the market data, for our position, we can say we want to know how big our position is, what is our realized profit and loss, what's our unrealized profit and loss, and what is our average entry price. So at what price did we enter this market? So that's the query. That's that query. We can stick that in our subscriptions array, which will be picked up by the init subscriptions function. So we don't need to change that. And in fact, if I run this without doing anything now, what we'll see, I think, is two different types of messages come back. We need the party ID. So the party ID is not defined. And what this is going to return now is two different types of messages, I hope. It may not if I gave it a party that doesn't have a position. I need to just check that. Did I give it the right party? This one. So that's this one. I believe I did. Need to think about what's going on with that. I think there might be a small error in the script. Let me just check something. There we go. It's working now. So it's kind of difficult to see, so I'm actually just going to kill the script. But this is the problem with when you're working with kind of real-time messages from all these coming back asynchronously. It can be difficult to see what's going on. But we did make a connection to two different streams there, market data and positions. And you can actually see here, we were getting back, on one line, we're getting back position data with positions here. And it has Aave die. It has open volume 5, realized P&L minus 43968. And then the next line is returning market data. So we're getting back alternately an update for our position and an update on the market. And you could subscribe to many of these and get as much data back as you want. And then the final thing we'll do in this script is think a bit about how we might want to handle that data and make this all a bit easier to see. So I'm going to define in the script two variables, markets and positions, which we'll use to hold the global variables, which we'll just use to hold the data about positions and markets. And in order to do that, we need to update the onMessage function. So we'll use this code here, which basically says, if I'm getting market data back, stick it in the markets global variable. If I'm getting position data back, stick it in the positions global variable. And so I'll update that on our stream2 script so that it does something useful with it. And then, you can imagine you might then use the data in those variables from somewhere else in your code to make decisions about maybe what a trading algorithm needs to do, or maybe expose that data over an API endpoint so that a user interface can create some graphs or something like that that's interesting. And what I'm going to do in this script is actually just stick a small REST server or a small kind of API in there, which has two endpoints, /markets and /positions. And that will just convert that data into JSON and we can see it in the browser. So in order to do that, I need to define a Flask server in Python, which are these lines here. And that can go here at the bottom of my script. And in my main function, I just need to connect to the WebSockets so that the data comes in, and then I need to just start the Flask server. So I've defined those endpoints there, which you can see. /markets is just converting the markets object to JSON, and /positions is doing to positions. And there's a small little detail in the script, which is I need to connect to the WebSockets on a different thread, so that that's basically running in the background, and then the main thread of the application will start the API. So I think that's going to do the job. Yeah, so I think that's going to do the job. So now if I run that again, yes, import Flask, and I think there's another one that I need. Threading. And yep, there we go. So we're running now, and it's a bit quieter now because it's not dumping everything to the logs. And hopefully we can just go to a browser now, and we'll see our API that we created return some data. Yep, there we go. And if we refresh that, let's have a look. Best offer volume is currently 42, and then it's 72 and 11. So this is updating now in real time with the information that's coming back over WebSockets. And we can look at positions, and we'll see our position that we could also see in the console. So we've got 5 open volume on RVDI, and you can see here that's consistent with what we see in the console, which is 5. And so that kind of covers how you can sort of stream data out of Vega. And I appreciate, because of the issues at the start, you have just a few minutes left now. And so the other example I was going to run through is how to then execute trades on Vega, and I'm going to try to do that really quickly. I'm not going to create a second script. I'm going to talk through the functions in this script and what they're doing. So I created this trade script here, and what this does is basically just submits random trades onto Vega. And so we just have a loop at the bottom, which loops once per second, and it calls a trade function. And the trade function essentially determines randomly, sometimes I'm going to buy, sometimes I'm going to sell. And it trades in a random size between 1 and 5. And it prepares an order to execute a market trade on the Aave DAI market. And so in order to do that, it first of all needs to call this getToken function. And getToken is actually going to talk to the local wallet server that we're running. So wallet server URL. And the reason it needs to do that is because you're essentially because you're submitting a trade, you need to do that on behalf of the identities that you created in the local wallet server. So that will return us a token, and we use that to authenticate with the Vega network when we submit our trade. And then the next thing we do is we prepare an order. So we'll pass the size, which will be a number between 1 and 5, and we pass buy or sell to this prepare order function. The prepare order function then says I want to trade this market as this party with this size on this side, and then sends a request to the node to say, please prepare this order. The node returns a message that we then have to sign and resubmit back to the network. And we do that using the wallet server again, because we sign it with our private key, which proves that we are authorized to trade on that market with the identity that we want to use. And so I'm going to put some log statements here just so you can see. So we'll print the token that we get back. We'll print the prepared order. And then we already print the outcome of submitting the trade. And so I'm going to run this script, and this is going to basically just submit random trades on Aave DAI. So nothing useful, but it shows you how you can submit trades and orders onto the network using the kind of infrastructure that we already set up with the wallet server and everything else. So let me just kill the script, and we'll run trade. So there it goes. And I can leave this running because it randomly buys and sells. On average, it will end up with 0 exposure, but it will fluctuate between being long and being short. In fact, I'll just stop it because it's once every second is a bit much. So let's just do every 20 seconds. And we can look at what's going on. So we get this big token back, which we use to authenticate. And then we get this blob back, which is base64 encoded binary data. And this is the thing that we sign and send back to the node. And then once we've signed it, we send it back to the node. And if it's successful, we just print this statement, executed market order with the size and the side. So size 1, side sell, size 3, side buy, and it will keep doing this. And what we can see in the console is that we're actually trading on here. So I'll leave that running. And you'll see that the open volume will go up and down as our, in fact, let me change it back to 1 second. Just so it updates. And you'll see the open volume goes up and down. So 16, 18, 19, as we do random buy and sell orders on this market. And that kind of covers pretty much everything. I suppose the other thing we can do is we can actually run the stream script as well at the same time. So because the stream script is actually listening to the same party and the same market, then rather than looking in the console to see things update, here we can actually look in our REST API that we created. So we have open volume 1 at the moment on RVDI, and then 5, and then -1. And you can imagine how you might put all of this together to create a system that listens to data from the network and can trade on markets on the network, to kind of build some really interesting applications on top of everything. I think that's about time and covers everything. And I guess we have 3 minutes for questions. So yeah, thanks for listening.
Yep, if anyone has any questions, please feel free to put them in the chat. I think we have one from Jake, who asks, what's the benefit of a stream of data versus just running a loop in Python and requesting on each iteration?
Well, when you're running a stream, you're going to get the data pushed to you only when an update's available. So if an update doesn't happen for 10 minutes, you won't get anything. And then if there are loads of updates in like 100 milliseconds, you might get 5 in a row. Whereas, so if you're polling for data and it's not changing, then it's extremely inefficient, because you're polling all the time and not getting any updates. And then when there are loads of updates in a short period of time, you're not polling fast enough. And of course, you don't want to be polling at like, every millisecond. APIs have rate limits and stuff like that. So with streams, you don't run into the problem of rate limits, and you get the information exactly when it's available.
Awesome. And just on my side, for the medium challenge, do you have any idea of the kind of things you're looking for in terms of dApps built on top of Vega?
I think in particular, anything that I suppose I can stop sharing, right?
Sure.
I suppose in particular, anything that kind of shows things that are unique to Vega that are not currently visible on like a centralized exchange. So a brilliant example of that would be the fact that on Vega, you can see how much money everyone is making or losing. You don't know who they are because they're pseudonymous in the same way people are on Ethereum and Bitcoin, right? It's just a public key. However, it's still really awesome that you can go on and see like exactly how much everyone's made or lost, and you can see their orders, you can see the markets they're trading on. So that might be one idea of something you might want to build, where you can actually go like, don't do what that guy's doing because he's been losing money for a month, kind of thing, versus like, oh, this guy looks like he's making loads of money, maybe I want to see what markets he's trading on and stuff. So that's like one idea. There's lots and lots of different things that can be done in that area. And then the other thing I would say is maybe some stuff around governance. So we didn't see that here, but I would encourage people to look on the kind of APIs, in particular around the governance side of things, so creation of markets. And you can, anybody can come along and propose new markets, and then those markets will behave in a certain way and based on the parameters that they use. And so kind of making that easy for people to understand would be really awesome, because it's quite complicated and involved. And there's lots that can be done there as well to kind of create markets in a good quality markets in a permissionless way. And the protocol has all the kind of mechanisms and parameters built into it to do that. But again, building visualizations and tools on top of that make it easier for people to get over that like knowledge hump would be really awesome.
Awesome. if we have any more questions, please feel free to put them in the chat. But thank you very much for that presentation. It's very nice to see what you can potentially build on Vega, and I'm sure we'll get some great submissions in the hackathon, especially given that nice prize pool that you've put there for the Hackathon students. But yeah, I think that's everything. No more questions have come through, so thank you very much, and
Cool.
thanks to everyone, all the participants, for sticking with us throughout the technical difficulties at the start. And this will be on YouTube as well, so if there's anything you want to go back over, you should be able to do that about probably sometime tomorrow.